Have you ever thought about walking to a destination? It seems simple, doesn't it? You just put one foot in front of the other. But what if I told you that logically you can never truly reach any destination at all? This isn't some modern riddle. It's a profound puzzle from ancient Greece. Imagine you want to cross a room, you take your first step, but an ancient philosopher named Zeno of Elea would stop you right there. He would present an argument so clever it has baffled thinkers for centuries. He would suggest that your journey involves an impossible task, completing an infinite number of steps. This is the heart of Zeno's Paradox, a set of thought experiments designed to challenge our understanding of reality. Are our senses reliable guides, or do they mask a deeper truth? Zeno's questions were serious inquiries into the fundamental structure of the cosmos. They still resonate today, pushing us to think harder about what it means to move, to exist, to be. So, prepare yourself for a journey through the landscape of an idea that seems to defy common sense. We will explore Zeno's famous arguments and see how they stumped the brightest minds of antiquity. And we will discover how new ways of thinking, particularly in mathematics, offered a way to understand this apparent impossibility. But the questions Zeno raised, they linger. They remind us that the universe is often stranger and more wonderful than it appears. Let's dive in. Who was this Zeno, this intellectual provocateur? Zeno of Elea lived in the 5th century BCE. He was a Greek philosopher from a town in southern Italy, then part of Magna Graecia. Zeno was a devoted student and follower of another philosopher, Parmenides. Parmenides believed that all of existence is a single, unchanging, eternal whole. What we perceive as change, as motion, as diversity, Parmenides argued it was all an illusion. This is where Zeno stepped in. He crafted a series of brilliant arguments known as paradoxes to defend Parmenides' claims. Zeno's method was clever. He would take common-sense assumptions about motion and plurality, and then, through rigorous logic, he would show that these assumptions led to absurd conclusions. His paradoxes are sophisticated logical puzzles exploring infinity, divisibility, space, and time. Perhaps the most famous are the dichotomy paradox and the paradox of Achilles and the tortoise. In the latter, the swift hero Achilles can never overtake a slow-moving tortoise if the tortoise is given a head start. Zeno's arguments were like intellectual bombshells dropped into the philosophical landscape of ancient Greece. He wasn't necessarily saying motion doesn't happen in our experience. He was saying that our concepts of motion, space, and time were riddled with contradictions if we assumed they could be infinitely divided. He forced everyone to think much more deeply about these fundamental aspects of reality. And in doing so, he set the stage for centuries of debate and discovery. Let's look more closely at one of Zeno's most famous arguments, the dichotomy paradox. Imagine you want to walk from one point A to another point B. Before you can reach point B, you must first travel half the distance. Okay, so you've reached halfway. Now, to get to B, you must first cover half of that remaining distance, and then half of what remains after that, and then half again. Zeno's argument is that this process of halving the remaining distance can go on forever. You will always have some tiny fraction of the distance left to cover. This creates an infinite sequence of tasks. You must complete an infinite number of smaller and smaller journeys. Each step is finite, but there are an infinite number of them. How can you complete an infinite number of tasks in a finite amount of time? It seems logically impossible. If you must complete an endless series of actions before you can reach your destination, then Zeno argues you can never actually reach it. Motion itself, the very act of getting from one place to another, becomes a logical impossibility. Our everyday experience tells us we move, but Zeno's logic, based on the infinite divisibility of space, seems to prove we cannot. This is the beautiful, frustrating power of his paradox. Zeno wasn't just trying to confuse people for the sake of it. His paradoxes had a very specific philosophical aim. He was a loyal student of Parmenides of Elea. Parmenides taught a radical doctrine. Reality is one, unchanging, indivisible, and eternal. Everything we perceive with our senses, motion, change, birth, death, is mere illusion. Zeno's genius was in showing that common sense assumptions about motion led to logical contradictions. His paradoxes were a form of. He was a philosophical defender, using logic as his shield and sword. Zeno's paradoxes sent shockwaves through the intellectual world of ancient Greece. Philosophers and mathematicians couldn't ignore them. One of the greatest minds to tackle Zeno was Aristotle. He recognized the seriousness of the challenge. Aristotle made a crucial distinction between potential infinity and actual infinity. He argued that a line segment is potentially infinitely divisible, but it is not actually divided into an infinite number of points. When you move across a distance, you are traversing a continuous whole. The debate also touched upon whether space and time are continuous or discrete. The core difficulty for the ancient Greeks was the lack of a fully developed mathematical framework for dealing with infinity and continuous change. While philosophers like Aristotle offered insightful arguments, a complete mathematical resolution to Zeno's paradoxes remained elusive. Zeno had exposed a deep conceptual crevasse in their understanding of the world. His questions spurred vital thinking. For centuries, Zeno's paradoxes remained a persistent intellectual itch. A truly satisfying mathematical resolution had to wait until the 17th century. This was when Isaac Newton and Gottfried Wilhelm Leibniz developed calculus. Calculus is the mathematics of change, dealing with rates of change and accumulation. It provides tools for handling the concept of infinity in a rigorous way. One key idea from calculus is the concept of a limit. Let's go back to the dichotomy paradox. You travel half the distance, then half of what's left, and so on. The total distance traveled is the sum of this infinite series. An infinite series of numbers can, under certain conditions, add up to a finite sum. The series 1/2 plus 1/4 plus 1/8 and so on is a convergent geometric series. The infinite number of diminishing distances Zeno describes actually sums up to the total finite distance. Similarly, the time taken for each segment also forms a convergent series. Calculus provides the formal machinery to prove this. It doesn't mean Zeno was silly, it means our intuition about adding infinite things needed a mathematical upgrade. The infinite sequence of actions is completed because each subsequent action takes progressively less time and covers less distance. Calculus showed that an infinite series of diminishing steps can indeed add up to a finite whole. Zeno's paradoxes weren't just mathematical puzzles waiting for a solution, they were profound philosophical inquiries. They forced humanity to think carefully about the nature of space, time, motion, and infinity. The true value of Zeno's work lies in the questions he posed. These questions spurred centuries of intellectual development. They highlighted the limitations of existing mathematics and logic. Zeno's legacy is not about being right or wrong. It's about the enduring power of asking fundamental questions. He showed that even the most obvious aspects of our experience can hide deep complexities. His paradoxes have served as a whetstone for sharpening our tools of logic and reason. They remind us that progress often comes from wrestling with ideas that seem paradoxical. Zeno's paradoxes, born in ancient Greece, still teach us a vital lesson today. They teach us about the incredible power of a well-posed question. Zeno didn't give us easy answers. Instead, he gave us puzzles that have resonated through millennia. These puzzles forced us to re-examine our most basic assumptions about the world around us. Can we ever truly reach our destination? The question itself is a doorway. It leads to deeper explorations of mathematics, physics, and philosophy. It shows how one person's persistent inquiry can shape the course of human thought. The journey to understand Zeno's paradoxes led to the development of calculus. It refined our understanding of infinity. It made us ponder the very fabric of space and time. Paradoxes are not roadblocks, they are signposts. They point towards areas where our current understanding is incomplete. The universe is full of Zeno-like questions. What is dark matter? What is dark energy? What happened before the Big Bang? By asking these questions, we propel ourselves forward. We develop new tools, new theories, new ways of seeing the cosmos. Every great scientific leap began with someone daring to ask why or how or what if. Zeno of Elea showed us that such questions are not just intellectual exercises. They are the engines of understanding.